Hello students, myself Manuj from Scholars Forum. Again, I welcome you all to this homemade video series of class 11th and class 12 topics. As you know, this video is being recorded at my home, so please pardon the background noise. Now, in the previous video, we discussed about the problems based on freezing point and for boiling point of solutions. Meaning we discussed about the numerical aspect of colligative property. Today, in the very same sequence, we will extend our topics. If you wish to go through those videos, you can find the link right up here. And let's start the first problem. So the first problem says, find the osmotic pressure of 3.42% weight by weight sucrose solution given density of sucrose solution is 2 gram per ml. Okay. Now, what is the formula for osmotic pressure? Osmotic pressure formula pi is equals to CRT. Okay. Formula for pi is equals to how much? CRT. What is C? C is molarity. C is molarity. Actually, the formula is ICRT. But I know what is sucrose solution. Sucrose solution, for sucrose solution I is equals to how much? 1. So I can directly write pi equals to CRT as well. But let's take I. Now, what is C? C is molarity. What is given to us? It is given to us that concentration is 3.42% weight by weight. So what is the meaning of this? The meaning of this 3.42% weight by weight is, if I take 100 gram of solution, so it contains 3.42 gram sucrose. It contains 3.42 gram sucrose. Meaning is clear. What is the meaning of this 100 gram solution of, what is the meaning of this 3.42% weight by weight? Good. Now I have to find molarity. For molarity purpose, I need volume of solution as well as I need weight of solution, moles of solution. So let's see. By this data, I can find moles of sucrose. Moles of sucrose will be how much? 3.42 divided by molecular mass of sucrose, that is 342, is coming as 10 to the power minus 2. This is the moles of sucrose I have. Okay. Now what is the volume of solution? For volume, finding the volume of solution, I will divide weight of solution by what? Density. So it will be 100 divided by 2. So how much we are getting? We are getting 50 ml. Okay. This is the volume I am having. Now let's find out the molarity. What will be the molarity? Molarity will be moles upon volume in ml multiplied by 1000, means 10 to the power minus 2 divided by 50 into 1000. Now I hope you can see how much we are getting from here. We are getting around, I hope you can see, 0 cancel out, 10 by 50. 10 by 50 means 1 by 5 means 0.2. So what is molarity of sucrose solution? It is 0.2. Good. Now let's put the pi is equals to ICRT formula. Now what is I? I is 1. What is C? C is 0.2. Now what is R? So there are 3 values of R. Values of R are 8.314. See the unit? Unit is joule per mole Kelvin. One more unit is there, approximately 2, but calorie per mole Kelvin. And one more unit is there, it is 0.0821 liter ATM per mole Kelvin, which is approximately 1 by 12. This value you can write as 1 by 12 as well for calculation purpose. Why? Because 1 by 2 is nothing but 1 by 12 is nothing but it is 0.083. Okay, so approximately I can take it as 1 by 12. So R will be how much? 1 by 12. Okay, now T. T means absolute temperature. They have not mentioned any temperature. So if they don't mention any temperature, you take T is equals to 25 degrees Celsius. That means 298 Kelvin. But for calculation purpose, we can take it as 300 Kelvin. Check the options. If options are very close, then don't take the approximation. If options are quite far, then only you take this approximation and take 298 Kelvin as 300. You can see by yourself that calculation would become very easy now. Now let's see. This happened. Now if you cancel it, it will go for 25 times. Okay, 25, 12 to the 24 carries 6, 6 12 5 is 60. Now 25 into 0.2, which is coming as 5 atm. This is the osmotic pressure of what? Our sucrose solution. Clear one? Good. Moving forward. The next problem is, if freezing point of CSA-CAA solution is minus 0.216 degrees Celsius, find its osmotic pressure. Data for KF is given to us. Okay. Pause the screen, give it a try. Okay. Now let's see how can we solve it. I hope by delta of freezing point you can find delta TF. What will be delta TF? Delta TF will be how much? It will be 0 minus 0.216, that is 0.216 degree Celsius. I think there should be no problem. Good. Now, once we have found delta TF, so what is delta TF? Delta TF is I into KF into M. This is nothing but 0.216 degree Celsius. Now, I don't know about I don't know about M. But about KF, I know. What is KF? KF is given 1.8. So I into 1.8 into M will be equals to 0.216. From here, if I calculate I into M, I will get 0.216 divided by 1.8. Let's simplify this. I think it is getting cancelled by 9. So 9, 200. And it is also getting cancelled by 9. So 9, 3. 9 3 ja, oh sorry, 9 2 ja 18, 3, 9, 24. Again 200, again 12. How much I am getting? I am getting 0.12. This is the value of I into M I am getting. Okay. Anything else I cannot find by this. I can find only I into M. Now what I have to find actually, I have to find pi. What is pi? Pi is equals to I C RT. I don't know about I don't know about C, but I know R, I know T. T is given to me, which is 300 Kelvin. Okay, now let's see. I told you earlier, if no data about molarity or molality is given, or if density data is not provided, so we will take molarity equals to molality. Is this clear? Now here, instead of I into C, I will write I into M, into R, into T. Now what will be I into M? Let's see. I is how much? I is 1. I into M is what? 0.12. What is R? R is 1 by 12. What is T? T is 300. So if you solve it, you will get 0.01. Multiply by 300, you will get 380. So this is the value of pi. I don't require value of I separately. I don't require value of M separately. I need their multiplication. Is this clear? Good. Let's move forward. Now let's see next question. Question is, we have a container in which at one side I have 0.1 molar NaCl and on another side I have 0.2 molar AgNO3. Clear? This side 0.1 molar NaCl and this side 0.2 molar AgNO3. Okay. The question is, at which side precipitate of AgCl will be formed. Again, I am repeating the question. If we have this container in which one side we have 1.1 molar NaCl, one side we have 0.2 molar AgNO3, and in the middle we have placed a SPM, semi-permeable membrane. Question is, at which side precipitate of AgCl will be formed? Whether it will be on left side or right side. Pause the screen. Try to solve this question on your own. Okay. Now let's see. I hope you understand. Answer to this question will be nowhere. No precipitate will be formed. No precipitate will be formed. Why? Because SPM allows flow of solvent only. It does not allow flow of solute. So AgNO3 or NaCl, they can never cross this SPM. So there will be no reaction between AgNO3 and NaCl. So you will get to see no precipitate at all. Okay. So answer will be no precipitate will be formed. Reason, STM allows only flow of solvent particles. Is this clear to us? Good. Now, next question is, the 4% weight by volume solution of NaOH is isotonic with C6H12O6 solution, means glucose solution. So find the molarity of glucose solution. Clear? Means we have isotonic solution of NaOH and C6H12O6 glucose. So we are asking you what is the molarity of glucose solution. Now I told you if two solutions are isotonic, two solutions are isotonic. If two solutions are isotonic, so that means pi 1 should be equal to how much? Pi 2. Please pardon the background noise. As you know, this video is being recorded at my home. Okay, so pi 1 is equal to pi 2. Now I told you as well that I1 C1 should be equal to how much? I2 C2. Okay, now let's see for NaOH. For NaOH, can you tell me the value of I? I will be how much for NaOH? It will be 2. Because NaOH is a strong electrolyte, it will dissociate into 2 ion. It will give you 2 ion per molecule. So that's my I equals to 2. Now let's see one more thing. They have said that we have 4% weight by volume NaOH. Means if I take 100 ml of NaOH, 100 ml of solution, so it will have 4 gram of NaOH. You understand the meaning of 4% weight by volume? Good. Now, here I need to find C's. C means I need molarity. So for that purpose, what I will do, I will see what I know here. I know volume of this solution is 100 ml. I know weight of solute is 4 gram. 4 gram means how many moles? 4 upon 40 moles. Means 0.1 moles. So what will be the value of C for NaOH? C means molarity. It will be 0.1 divided by 100 multiplied by 1000. This is the formula for molarity. Moles of solute upon volume of solution multiplied by 1000. So how much I am getting? C. Cancel, cancel, cancel means I am getting 1. This is the molarity of what? NaOH. Okay. Let's see here. So I1 is what? 2. C1 is what? 1. Now what is the I2? I2 means for glucose. What is I for glucose? Glucose I is 1 multiplied by C2. So that gives us C2 equals to how much? 2. So molarity of C2 solution, glucose solution is nothing but it is 2. Clear? Let's move forward. Now next question is, we have 200 ml of 0.1 molar NaOH and we have 300 ml of 0.1 molar KNO3. We are mixing them together. So whatever resultant solution will be coming, we have to find its boiling point and osmotic pressure. Okay. Kb is given to us 0.5 kilocalorie mole kg per mole. Now, whenever this type of question arises, what should we do? Whenever we have mixing of more than one solution, when we have mixing of different type of solutions. So in such case of mixing, our aim should be, we should find effective molarity or molality of solution. And in this thing, we must include association and dissociation as well. Now what I want to say, here what is happening, we have 200 ml 0.1 molar NaOH. So can you tell me how many millimoles of NaOH I have added? Millimoles of NaOH added will be molarity into volume in ml. How much? It will be 0.1 into 200. That is how much? 20. Now this is millimoles of NaOH, but you know that each NaOH when dissolved in water will give us 2 ions, isn't it? So effective millimoles of NaOH. Can you tell me how much it will be? It will be I into millimoles, like 2 into 20, that means 40. So 40 millimoles effectively, including the effect of I, are being produced by what? NaOH. Okay. Now, effective millimoles of, let's see this, KNO3. How much? It will be 0.1 into 300. That means 30. But is it the correct answer? Effective millimoles of KNO3 will be 30 only? No. I must multiply it with I as well. Isn't it? This time I skipped this step. Are you getting this thing? Good. Now, so I into 300 into 0.1. So what is I for KNO3? KNO3 will give us 2 ion, K plus and NO3 minus. So 30 into 2, that is 60. Okay, good. Now, total millimoles. Total effective millimoles. Can you tell me how much it will be? It will be 60 plus 40. 60 coming from KNO3, 40 coming from NaOH. So total it will be how much? 100 millimoles. Okay. Now can you tell me effective molarity? Effective molarity will be how much? It will be millimoles divided by volume in ml. Okay. Now tell me what is the effective millimoles we have? Effective millimoles we have 100 divided by what is volume in ml? 200 ml and 300 ml are mixed. So effective volume will be 500 ml. That means 1 by 5 means 0.2. This is the effective molarity of our solution. Is this thing clear to us? First of all, good. Now, we have to find BP. BP means we need to find delta TB. We need to find delta TB. Without delta TB, we cannot tell the boiling point of any solution. So what will be delta TB here? Delta TB will be equals to I into KB into M. Now let me tell you one thing. There is no need to write I now. Why? Because we have already considered the effect of I. See, here I considered, here I considered. So here we don't need to consider I. And for me, whatever NaOH will be causing me colligative property, the same will be caused by KNO3. That's why these two solutions are same for me. Okay, now let's see. So delta TB equals to how much? It will be KB 0.5. Now I don't know molality. But I told you, if no data about molarity is given, we will take molarity equals to molality. If no data about density or no data about conversion of molarity given, let's take molarity equals to molality. So 0.5 multiplied by how much? 0.5 multiplied by 0.2, it will come as 0.01. This is the value of what? Delta TB. Now what will be the TB? What will be the TB new? TB new will be 100 plus 0.01. What is 100? 100 is the boiling point of water. If no solvent is given, we will take it as universal solvent, water. So how much we are getting? We are getting 100.01 degree Celsius. Is this clear? Good. Now one more thing we have to find, it is osmotic pressure. So what is osmotic pressure? Osmotic pressure will be pi equals to ICRT. Now do I need to put this I here? No need for phi because already considered I. So now put the value of CRT and tell me the answer in the comment section. Okay, let's move. Now again a question of mixing. Here what they are saying, if we have two solutions, one solution has osmotic pressure pi 1 and one solution has osmotic pressure pi 2. We have taken V1 and V2 ml of both the solution respectively and we are mixing them. So now what we have to do, we have to find the molarity of, we have to find osmotic pressure of resultant solution. They have given one thing, that please assume no dissociation or association. If they haven't said this, we still will take I is equals to 1 because no information regarding solute is given to us. Okay. Now, how will we approach to this question? Again, the very same technique. We have to find somehow effective molarity. Somehow we will focus on finding effective molarity. So let's see. So for solution number 1, I is equals to what? CRT. So what is C? C is moles upon volume in ml multiplied by 1000 RT. This is your pi. This is the formula for pi. Okay. Now what is pi given to you for first solution? Pi 1. Pi 1 will be equals to what? N1 upon V1 into 1000 into RT. Okay. Now can you tell me the value of N1? N1 will be how much? Pi 1 into V1 into, pi 1 into V1 divided by 1000 into RT. This is the value of what? N1 means moles present in solution number 1. Now what will be N2? Similarly, N2 will be what? Pi 2 V2 upon 1000 RT. This is the N2 is what? N2 is the moles of solute present in solution 2. Now total moles will be how much? Total moles will be, it will be nothing but it will be N1 plus N2. Is this clear? Now, effective molarity. Effective molarity. What will be effective molarity? Effective molarity will be N1 plus N2 means moles of solute divided by total volume in ml. What is total volume in ml? V1 plus V2 multiplied by 1000. Is this clear to us? Good. Now what will be pi effective or pi resultant? It will be CRT. What is C? C is effective molarity. Let me write here EFF. So what is effective molarity I am writing here? I am writing here N1 plus N2 divided by V1 plus V2 multiplied by 1000. Are you getting this thing? Multiply by R into T. Now let's put the value of N1 and N2 that we have already solved here. So let's put those values. So what is N1? N1 is pi 1 V1 upon 1000 RT plus pi 2 V2 upon 1000 RT divided by V1 plus V2 multiply by 1000 RT. Okay, now I hope you can see this 1000 RT, this 1000 RT and this 1000 RT will be cancelled out. LCM will be 1000 RT and it will be cancelled out. So how much we are getting? We are getting pi effective is equals to pi 1 V1 plus pi 2 V2 divided by V1 plus V2. Is this clear to us? Okay, good. So whenever mixing question comes, we have to deal like this. Somehow we should try to find moles produced by sample 1, moles produced by sample 2 and net molarity. Okay, until now we solved the question based upon colligative properties. Now in the next video we will be moving forward. Your task will be attempt all the questions given in the DPP. The link you can find in the description as well as in the comment section. Solve them, leave your doubt as a comment. I will reply as soon as possible. Okay, till then keep studying. Have a good day.